5.5. Solving exponential logarithmic equations. You're going to solve exponential logarithmic equations. It's with algebra. You'll be going back and forth between exponential and or logarithmic functions. So base exponent properties. So here's more properties for you to put on that note card. For any a greater than 0, a cannot equal 1. Then a to the x power equals a to the y power means that x must equal y. So anyways, if your bases are raised to this, if you have the bases the same, you just have to get your exponents to be the same. So on this one here, 3 to the x equals 3 to the 8th. We can cross out our bases and simply claim x's has to be 8. For these to be equal, x would have to be 8. So this one here, same thing, 5 to the 2x equals 5 to the 28th power. Cross out the 5s, cross out the bases, and play with the exponents. 2x must equal 28. Therefore, divide both sides by 2, x would have to be 14. And we plug 14 back into here, and we get 2 times 14, or 28. Okay, so a couple more examples. So this one doesn't have a base on it, so, or not a base, it doesn't have a base of 4, so you need to get these both to be a base of 4. So this is already 4 to the 2x minus 5, and 64 is 4 cubed. Now, you may not have this thing to be memorized, but there's certain things you should have memorized at this point, like all of your perfect squares between 1 and 20, or at least 1 through 15. And then your cubes through 5, say 6 cubed, and so on and so forth. Okay, now that my bases are the same, I can cross them out, and I'm left with 2x minus 5 must equal 3. Nice little algebra problem. Add 5 to both sides, and we get 2x equals 8. Divide both sides by 2, and we get x equals 4. And if we can double check it. 2 times 4 minus 5 gives us 8 minus 5, which does equal 3. Okay, this one here. 2 to the x squared plus 4 equals 1 to the 8th. We got to get this guy to be a power of 2. Okay, so back to this one. So I have 2x to the x squared plus 4x equals 2 to some power. So we know that, or something you should know, 8 is equal to 2 cubed. But I have 1 over 8. So this is really 1 over 2 cubed. And to get this out of the denominator, we change the exponent to negative. So this would be 2 to the negative third power. So now I have 2 to the x squared plus 4x equals 2 to the negative third. We can drop our bases, and we're left with x squared plus 4x equals negative 3. Remember, polynomials, quadratic specifically, to solve these, it has to be equal to 0. So I'm going to add 3 to both sides. So x squared plus 4x plus 3 equals 0. And factor this. So we can use that wagon wheel idea that I've got some of you going, yes, I know how to use it, some don't. Need factors of 3 to add up to 4. So this is just 1 and 3. So x plus 1, x plus 3. Those who know the wagon wheel know to divide by the negative 1, the leading coefficient. Change the signs, and you get x equals negative 1 and x equals negative 3. Now we need to talk domain. Domain on logarithms. Must always be greater than 0. So in our case here, well, we're not even actually in logarithms. We'll have to just make sure that we get a positive, we get the value back we want. So we don't need a domain yet. We'll talk about that in a little bit. So if I put in, we got to check, make sure the answers work. So -1 squared plus 4 times -1 gives us 1 minus 4, which is -3. Remember, that's the one we're looking for, the exponent of -3. Now when I put -3 in, I get -3 squared plus 4 times -3, or 9 minus 12, which is -3. So they both work. Either answer will work for us. Okay, so the next property they have for any m greater than 0, n greater than 0, a greater than 0, and a cannot be 1, m equals n implies that log base a of m equals log base a of n. Anyways, you can take the kind of like squaring both sides, you can square root both sides, you can take the log of both sides, and so on and so forth. So the one hint they do give you is that anytime you see an e, use the natural log, but otherwise we would go to base 10. So this one here, we're just going to simply write log of 62 to the x power equals log of 51. Because keep in mind, we are looking for an exponent that's going to get us where we want to be. So use the power rule to bring the x forward. So now we have x log of 62 equals log of 51. Divide both sides by log of 62. And we get x to be log of 51 over log of 62. Now we use this concept a lot in calculus for those of you who are going to be jumping into calculus. And when I throw this into the calculator, I get a value of approximately 0.95267. And if I was wanting 4 decimal places, 0.9527. Okay, so this one, 10 to the x equals 2 to the 2x. So the log of 10 to the x is going to equal log of 2 to the 2x. Bring our powers down. So x log of 10 equals 2x log of 2. Now remember, the base and the value are the same. That's just 1. So now we're down to x equals 2x log of 2. Move the 2x's to the other side. So I have x minus 2x log of 2 equals 0. Factor out the x, so I have x by itself. So that gives me x times 1 minus 2 log of 2 equals 0. And yes, we could change this to 1 minus log of 4, 2 squared. And we divide by this guy, x equals 0 over anything, 1 minus 2 log, is going to give us x equals 0. So the only way to make this one equal is if x was 0. Because 10 to the 0 power is 1, 2 to the 0 power is 1. The only way to get that one to work would for them to be 0. Sometimes that's just the way it goes. Okay, let's try a couple more. Okay, it's still the same power rule going on, same rule. Now we have e, so we're going to do natural log. So natural log of e to the negative x must equal the natural log of 5 to the 3x. Use power rules. Negative x natural log of e equals 3x natural log of 5. This is going to be 1. This is going to be 1. So I have negative x equals, oh, I'm sorry, yeah, equals 3x natural log of 5 putting both to the same side, negative x minus 3x natural log of 5 equals 0. Factor out the x. So I'm left with negative 1 minus 3 natural log of 5 equals 0. And if I divide by this guy, it won't make a difference because x would have to be 0. Okay, next one. They went back with you. We can do the logs, but there's no purpose in doing the logs on these because I've got, that's going to be just a long route there. But since that's the point they're trying to make, we'll go ahead and do it. Log of 2 to the x plus 6 equals log of 2 to the 4x. So we get power rule, x plus 6 log of 2 equals 4x log of 2. Well, I can divide by log of 2, and those two lovingly disappear, and we're left with x plus 6 equals 4x. Now, we did not have to go this way. That's just the point they're trying to make. Subtract x, and I get 6 equals 3x, divide by 3, and you get x equals 2. If I put this in, 2 plus 6 is 8, 2 to the 8th, 4 times 2 is 8, 2 to the 8th. So we know it works. Okay, couple more. So log 4 to the x plus 3 equals log of 5, 2 minus x. Power rules, x plus 3 log of 4 equals 2 minus x log of 5. Divide by log of 4. I'm pausing, wondering if there's a quicker, easier way of doing this, but probably not. Divide by log of 4. I get x plus 3 equals 2 minus x times log of 5 over log of 4. And no, you're not going to throw this in the calculator and get a value. Divide by your 2 minus x. I think I'm going the long way, but I don't want to erase everything at this point. Those cancel out. I'm going to pause. I think I'm going too far out the long way, and I'm going to end up going right back to where I should have been. Okay, I'm going to apologize because I went way too far out the long way. So I'm going to just start it again. Log of 4 to the x plus 3 equals log of 5 to the 2 minus x. First two steps were fine. After that, I kind of messed up. X plus 3 log of 4. Otherwise, I would have gotten right back to this. Where I was going, I would have gotten right back to this. 2 minus x log of 5. I need to distribute, so I have x log of 4 plus 3 log of 4 equals 2 log of 5 minus x log of 5. Now at this point, I need to get my x's on the same side. So I'm going to add x log of 5 plus x log of 5. And I'm going to move my constant to the other side. Minus 3 log of 4 minus 3 log of 4. So I now have x log of 4 plus x log of 5 equaling 2 log of 5 minus 3 log of 4. We're going to do some cleanup on this side. On this side, we're going to factor out the x. So I have x times log of 4 plus log of 5 equaling, I'm going to take my powers back since these are whole numbers. I'm going to take my powers back up here. So this is going to become, so I'm going to here, which is going to give me log of 25 minus, and then I'm going to bring this 3 over here, and I get log of 64. So we have 2 steps we can do here. We can use another couple more properties, or we can just simply divide. We need practice on properties, so we're going to do properties. Plus means multiply, so I have x times the log of 4 times 5 equaling the log of 25 divided by 64. So x log of 20 equals log of 25 over 64. And divide both sides by log of 20. So we get a value of x equals log of 25 over 64 divided by log of 20. Now this is an exact value, but we can throw this in the calculator and get an approximate value of negative 0.3138. I know a lot of math to get there, but we got there. And it's all using properties. So you've got to know these properties, kind of like the trig identities. You have to know there's just not as many identities that you have to worry about. You just have to know what you're looking at and go for it. So log both sides, brought down the power rules, distribute, that's a basic algebra problem, distributed, so we got, we distributed, then we moved all of the x's to one side, all the constants to the other, just like you would in algebra, just that these have logs on them. Factored out my x's. On this side, I moved my powers back up, so I didn't have the powers to worry about anymore. This was a minus, so it's a division. This is plus, so it's multiplication, and we simplified it and got it down to something we can work with. If we have to, we can go through one of these problems in class. Okay, the next one, same thing. Log of 2 to the x plus 1 power equals log of 5 to the 2x power. Bring the powers down. X plus 1 log of 2 equals 2x log of 5. Distribute here, x log of 2 plus log of 2 equals 2x log of 5. Okay, I'm going to move this x over here since there's nothing else to move. So I have negative x log of 2 minus x log of 2. So I have log of 2 equals 2x log of 5 minus x log of 2. Okay, factor out the x. So I have log of 2 equaling x times 2 log of 5 minus log of 2. Just like before, I'm going to take care of the power here. I'll go ahead and move the power up. So we have log of 2 equals x times log of 25, 5 squared, minus log of 2. And this is a division. So log of 2 equals x log of 25 over 2. Then we divide by log of 25 over 2. And then we lovingly throw this into a calculator. And we get an x value to be approximately 0.2744. And we can go back to the original problems, double check it, make sure it works, yada, yada, yada. I know this is a lot. This was even a very long video. Do come in with questions on these if you have questions on these last few. Okay, that gets you started on the first 25 problems. Well, really 12, about 6 or 7 problems I'm assigning here if I'm doing every other odd. So that would be a good luck.